the may be true or can be true questions. The standard question is on the lines of which of the following may be true, and you would be given certain choices. The correct approach for solving these questions is to get just one case where the given condition is met. When you get even one true, you can select that option. When you fail to get even one case, it means that you need to eliminate that answer choice. Let's take an example. Which of the following can be true? And look at this case now. The approach is we need just one case where such a condition is possible. So imagine for a value such as x is equal to 0.1, x cube would be the smallest, then x square, and then x. Of course, this would not hold for a lot of values, but that is not important. In these may be true or can be true questions, we need just one case in which the condition is met to select that particular option. So this should be selected. Look at this. Again, there will be a lot of cases when this condition would not be met. They are not important. We should try to get just one case where this condition can be met. And imagine for a negative value and a small negative value, say negative 0.1, see x would be most negative, x cube would be lesser negative, and x square will be positive. So this is also possible. Let's take one more example. When do you think x square will be greater than x raised to power 4? This would be the case when x is a small negative or positive number, such as say x is equal to 0.1. This condition would be met. And for x is equal to negative 0.1 also, this condition would hold. But see, in either case, x cube will not be greater than x square. In this case, x square will be greater. In this case of negative 0.1, x cube would be negative, and therefore x cube would be the smallest of the three. So see, for this case, we are not able to get even one case where this condition can hold, and therefore we must eliminate this answer choice. Sometimes the question is also that which of the following cannot be true. So such cases where you failed to find even one case where this could be true would then be selected, because this is the one which cannot be true. Let's take one more case. Once again, our approach is going to be the same, that we need just one value for which the two conditions can be met. Now it's given that x is greater than x square. When do you think this is going to be true? Of course not for negative values, of course not for large positive values. This is going to be true when x is between 0 and 1. Again, an example such as 0.1. But in such cases, x would not be greater than 1 by x. In fact, 1 by x would always be greater than x. So once again, we will not be able to find even one case where this can be or may be true, and therefore this should also be eliminated. So this is the approach for may be true or can be true questions. Let us now look at the must be true, should be true, or always true questions. The standard question is which of the following must be true. The approach is that in these questions, try to get one case where you are able to prove a statement false. When you get even one false, you can eliminate that answer choice. When you can't get even one false, that means that answer choice has to be selected. Let's take an example. Which of the following is always true? And look at this one. Our approach should be that we should get just one false. We know that 1 by x is greater than x. When is this possible? When x is between 0 and 1, a small positive value, or when x is a great negative number, such as let's say when x is equal to say -5. So we take an example 0.1 and we take an example say -5. So see, x is greater than x square will apply in this case, but it will not apply in a value such as -5. So we have a case when x is equal to -5 that 1 upon x negative 0.2 is greater than x negative 5, but x is not greater than x square is positive, and therefore we can eliminate this. Once again, the approach is that we just try to get one case where we are able to say that a statement is false. We eliminate that answer choice and we move on. When we are not able to get even one case, it means false is not possible. The statement is going to be always true. One more case. If x is greater than 1 by x, 2x is greater than x. X is greater than 1 upon x. When is this possible? Again, this is possible for big positive values, say x is equal to 5, but it is also possible for small negative values, say x is equal to negative 0.2. See, negative 0.2 would be greater than 1 upon negative 0.2, which would be negative 5. But in this case of negative 0.2, 2x would not be greater than x. So once again, we got one case where we could say that yes, x is greater than 1 upon x, but 2x is not greater greater than x, and therefore this statement is false. We got only one case where we could say that the statement is false, and we could eliminate this one. One more, it's given that x is greater than 2x. When is this possible? Of course, when x is negative. Okay, now 1 upon x is greater than x. Look at this. If we take x is equal to negative 0.1, see, x is greater than 2x, yes, but 1 upon x would become a big negative number. It would become negative 10, which would not be greater than negative 0.1. So once again, we have got one case where we could say that this statement is false. If you're wondering how I am choosing such values, negative 0.1, negative 0.2, all of these, I have taken this up in detail in our inequations videos. You may want to watch those conceptual videos. One more example, it's given that x square is greater than x, and we want to prove that x cube is not greater than x square. We want to show this to have a case of false here, and of course, if we take some negative value of x, say negative 2, x square will become 4. See, this part is met. The first condition has been met, but the second condition would not be met because x cube would become negative again, and this would not be greater than 4, the value of x square. So even this should be eliminated. We get one case of false, and we can say that no, the statement doesn't have to be always true. Let's look at the fifth one now. X is greater than 1 upon x. When is this possible? When either x is a big positive value, such as x is equal to 5, then x is greater than 1 upon x, or x is a small negative value, say something like negative 0.1. See, x is going to be greater than 1 upon x. 1 upon x will become a big negative number. And in both the cases, this is going to hold, that x square is greater than 1 upon x. See, for 5 also, and for negative 0.1 also. So in this case, we will not be able to get even one false. So we can't get even one false. That means this statement must be always true. So this is the approach for solving must be true, should be true, or always true questions. Largely, they are all the same. This was the concept, guys. GMAT shorts are deliberately kept brief. For an elaborate explanation, please refer the stage 1 videos. Thanks for watching.